Do you wonder sometimes how much energy is created in Ontario or in your area? Do you ever wonder sometimes what kind of energy is produced and how much we are using in our society? So here's an example about Ontario that I talked to about information I talked to my students this week, and that raised a lot of questions. So we're here to look at how the supply of electrical energy is available in Ontario. If you have any questions as we are going along, put your comments or clarification questions in the comments below. I'm always here to answer your questions as we are progressing. And if you're my students, you will notice that these graphs you've seen in class already. So let's see if we can look at this graph a little bit more. So this graph here shows the supply of energy, electrical energy from Ontario. So if I go here, so this is part of Connecting Today, Powering Tomorrow. It is the power data from Ontario. So this information I have, let's see if I can make it, let's see if I can update it. Very nice. So it's a bit more updated. So let's see. So this is the power data for Ontario as of Saturday, May 18th, 2024. So here what you can see is that we have an Ontario demand of about 14,444 megawatts. When I did my first show this morning, it was about 13,300 at about 8 a.m. today. So there's an increased demand during the day. We can also see that Ontario is also creating energy and selling it to other environments. As you can see here, we also have a variety of sources of energy. The first one is nuclear. Nuclear is about half of the energy from Ontario. So we'll have a quick look at that later on. We have about a third of the energy from hydroelectric energy. We also have gas. So when we have gas here, this is natural gas for the most part, because we do not have coal power plants here in Ontario. We also have wind energy. So the wind picked up a little bit. We have solar energy that is getting better as well as the day is progressing. And there was no biofuel energy recorded at 8 this morning. So let's look at here the supply. So let's see if I can go over a week. I think that's more fun. There you go. Perfect. So here we have a graph that tells us some information about the energy production. So here, so as we go along, so the first one we're going to look into, and here you could see how so let's look at this time so you know exactly how much is produced. So right now at 10 a.m. this morning, we have the nuclear energy at about 8,000 megawatts. Now, what's interesting about nuclear energy, let's see if I can get rid of this table. There you go. The nuclear energy is that orange segment at the bottom. So I can show you the legend here. So we have here the nuclear energy, nuclear energy in orange. So here what we have, we can see that the nuclear energy is a fairly stable amount of energy from Ontario. The reason for that is that a nuclear power plant is amazing, but it's much harder to, it's not like a switch on and off where we can use it anytime and change the output easily. So here what we have, we can see that for the first 4 days of the graph, we have a very consistent production, a very constant production of electricity at about 7,500 megawatts. But then we realized here on the May 16 that we have an increase, so they're playing it a little bit. The reason for that is that I know that in the last few years they've been refurbishing 1 or 2 of the reactors in Ontario. So very soon, so they're doing some tests to see how we can start those again. Now, the other source of energy we have in Ontario, so let's put here the table. Going from the bottom, you have 4,900, so about 5,000 megawatts, and it's in light blue here. And the light blue is hydroelectricity. So let's see if I can look at the legend, hydroelectricity here. You could see with hydroelectricity, we have a third of the energy coming from them. That's quite amazing. And you're going to see, well, where's that energy from? Most of it is from Niagara Falls. So here's a quick picture just for fun. Very good. So if you look at this here, this is a picture of Niagara Falls. What happens, so here you have a building of the old electric power plant, and so they are redirecting some of the water from the fall into big tunnels, and here going further south, they are getting turbine to turn. So this is something that started not too long ago. It was, I think it's maybe 2007 or so, plus or minus a few years. I apologize for not having the exact date. But what happened is here we have a difference in potential energy. And it's a great place to do hydroelectricity because we have tons of water and water is running all the time. So going back to my graph right here, you could see that the quantity of energy from Niagara Falls is fairly consistent. Now, we have a valve that we can open and close, so we can play a little bit with how much energy is being used. So this is fairly consistent. The other one that is interesting is the energy in green. So in green here, as you can see, it is in wind. So here at about 10 this morning, the wind was 194 megawatts. But if you go back here on May 13 at about noon, it was about 2,500 megawatts. So from 2,500 to, so here we had about 12 times more wind power. And the reason for that is wind comes and goes. It's very hard to control. But when it's available, then it is very free. It's free power coming towards us and may as well use it as much as possible. So here you could see that during the night of May 13, here we had nuclear energy, we had hydro, we had very few megawatts from gas, and we had 2,500 from wind. So most of it, they're creating no carbon dioxide or any emission. That was amazing. Now you could see as well that as the cycles are going, so during the day, so around between 6 in the morning and 6 at night, you could see that there's an increase in energy demand. Then it goes down, then up again. So every day it goes up and then comes down. Do you have an idea why? Let's have a look. Yes, you're right. It's about the time of the day. So right in the middle of the day, people are waking up, getting up, starting to use energy. And on top of that, we have manufacturers, we have warehouses, we have people going to work, adding more demand on the energy. And as the day is coming to an end, around 5 or 6 in the evening, the demand is going down indeed. So if you're wondering how come sometimes the energy is cheaper during the nighttime, it's that because we are producing energy, but there's so much less demand that we are keeping our nuclear power plant going. We have water from Niagara Falls and a few smaller hydroelectric plants, and therefore energy is available, and they just want to make sure that it's easier to have someone use it and get some money than stopping completely the plants. Good. Very nice. So going up and down every day, you could see that in yellow. So here, if you go right now, we have solar energy is at 208 megawatts. But if you go during the night, we have 0 megawatts. So the sun is a small portion of the energy that we are using. So that's quite nice. As you can see, we're not using any biofuel from what we can see here. There was a little bit yesterday, like in the morning, just to get things started. And that's beautiful. So if you look at the graph, there's one color that we have not talked about. And that one color, let's see if we can look at the legend, see if I can change the way it looks. It is here, gas powered generator. So what does that mean? So let's look at the graph again. So let's see. Okay, so we've got our graph here. So we see that nuclear energy is constant. The hydroelectric power is also fairly constant. We don't know when the wind comes or go. We have a bit of control over the sun. So there's one thing that we do know that every day there's more demand during the midday for electricity. So that means that we need a way to turn on the switch to create energy if we need to, and turn off the switch when we don't need that anymore. And the easiest way to create energy for that is using natural gas. And the reason for that is that they're just a generator. So it's very easy to turn on a generator or turn out the generator, or increase how much power you can get. The more power you need, the more gas you use. I think that's fair for that. But as you can see, okay, let's see. If you look here, for example, on May 14th during the night, the quantity of gas powered generator is much lower during the night than during the day right here. So during the day, we have here 3,500 megawatts, and during the we have 1,400, so about half of it during the night. So here we have 3,500 megawatts, but right in the middle of the night, we have 1,200, so about 66% less. The beauty with that one is that generators are creating electricity as needed, but it's also creating gases. So pollution, carbon dioxide, a few other gases, including sulfur, including nitrogen. So what happens is that we want to minimize them. So the best way to minimize it is to take advantage of nuclear energy, the hydroelectric energy, wind, and so on. But when we need energy to make sure the economy is working, we need power. So here you could see how our province is increasing the use of gas generator when needed, and then they're shutting it down or lowering how much we're using gas when it's not needed. And that's the beauty, I think, of what we're doing in Ontario. Now, could this be better? Most likely. If you have any suggestions on how we could improve that, please put it in the comment below. Because as you're looking at some of the news, for example, so there's about 14 million people in Ontario. In the last couple of years, we had an input of about 1.2 million new immigrants. So there are more and more people coming to Ontario, and they're saying that the demand for energy could possibly double in the next 25 years, knowing that we'll have more people. More people means that we can have a much stronger economy, and therefore we need more energy, knowing as well that the electric cars, electrification of networks are also creating a demand on the energy. So what will happen in the future? That's a good question, but this is what is happening right now, and I think it's quite nice. The next thing I'd like to share with you is this map. I thought it's quite nice. I found this morning when I was doing some research for this presentation. So here we have the map that shares with us what kind of energy sources we have in Ontario. So I'm sure that different territories would have similar type of maps or information available. So if you look here on this, so Sir Adambeck is the big power plant here in Niagara Falls right now. And as you can see, we have water here. And the other ones, if we want to have hydroelectric dam, is further north here of Ontario, going all further north, because there's a lot more water. There are rivers, and what happens is that there's less, how can I say that? Less people in city, and therefore having hydroelectric dam is easier. Now, if you have rapids, then it's easier to redirect water to avoid too much inundation. So you could see that hydroelectricity is quite big in Northern Ontario, and here in Southern Ontario, we just have here at Niagara Falls. You're going to say, how come we don't have hydroelectric dams here in Lake Erie and here the southern part of Lake Hurons here? The reason for that is that you cannot create hydroelectricity with this flat surface of water. You actually need a change in elevation, so that water from a higher elevation going down to a lower elevation will have energy that can be used. So if someone are saying, well, there's so much water in Lake Erie and Lake Ontario, how come we don't have more hydroelectricity being produced? That's the key reason. Niagara Falls is great because we have the falls. Let's see if I can show it to you again. It's always nice. So we have the falls, so big difference in potential energy. Therefore, it's possible. So the other way we can produce energy, so in the southern part here of Ontario, and I'll have to see if I can find pictures, there are fields of, you can see tens and tens of windmills that are producing electricity. These are fairly flat areas when it's coming from a long way. So when you're looking at the energy production, when it's can be quite big, the reason for that is that we have quite a few of those fields. Could we do better with wind? Most likely. But keep in mind, there's a limitation on the wind energy, because if there's no wind or less wind, it's trickier. Very nice. The nuclear power plants. So we have here two. One is Pickering and the other one is Darlington here in the eastern part of Ontario. And there's another one right here, which is the Bruce Nuclear Complex. So there are three nuclear power plants here in Ontario. Something that is fun, I know that the federal government was able to set aside some amount of money, about $100 million, to work on micro reactors. So here, if you look at the reactors here for nuclear energy, about 73 megawatts of electricity are being used. So let's say on average, each of the power plants are created 2,500 megawatts. So here they're looking for ways to create mini reactors, so micro reactors that will be able to create energy, maybe less than 100 megawatts each. And the beauty would be that we could transport those micro reactors much more easily where energy is needed. So here in the southern part, it's easy because the density of people is quite high. But if you go further north, here the density of population is much less. So yes, we having little hydroelectric dams here and there and plants is helping smaller areas. But if you look in this area here, right in the middle, you may have First Nation group here. You need power, but you need power line to bring electricity from this plant to that plant. But imagine if you could have a micro reactor that you can bring with a truck or you can bring with an helicopter. You could actually provide energy for people in further north where resources and infrastructures are not as well defined. Because wires, they require a lot of metal, a lot of resources to set them up, and therefore microreactors, I think, will be a must in the future. That's what I think anyway. With respect to the other parts, we have the sun energy. So here from when I go from Toronto, so here we have some solar farms. I remember seeing those along the highway. I've seen these ones here as well. And there are some here further north. The difficulties with going further north is that the higher up you go in latitude, the more the sun, it comes in at an angle. So the focus of solar energy gets weaker and weaker as we go north. So here will not be as efficient. But here we have quite a few of them as well. We have a gas power plant. So here, gas power plants are great because it gives us energy right away when we need it. And you could see here, there's one close to Ottawa right here, further south. And around Toronto, there's quite a few of those. And the reason for that is that there's a high quantity of people. So maybe if you were to take this line right here, I don't know, maybe 60-70% of the people in Ontario live under this line. And therefore having gas power plants allows us to quickly give energy if needed. So here they mention charbon. Let's see if I can get the English version. I think that'd be fun for you. So here they have, oh, look at this. That's interesting. So I like that. So you could see that the French version of the map says that there are some coal power plants, but we don't have coal power plants since Kathleen Wynne was a premier here in Ontario, and she shut them down completely. And here you could see this, not even any sun generated energy. However, so in early 2000, Ms. Wynne canceled all the coal power plant, and the reason she was able to do that is that we had here the different. Oh, look how the map looks different right now. Interesting. So the French map is quite outdated. I'm going to have to call them to see what they can do about that. So here, the question was that there's no coal power plant, and the reason for that is as soon as we got the new power plant, the new hydroelectric power dam in Niagara Falls, she was able to shift where the energy was from. Until that hydroelectric plant was created, there was no way Ontario could live without the coal power plant. So that's something that has changed quite a bit. So this, and biofuel. So here, if you go further north, you have an idea of where the biofuels are. So biofuel is on the north here, and the reason why it's further north is we have a healthy forestry economic sector. So what happened is that when you cut trees for the lumber industry or otherwise, you often have waste materials, and they're using the waste materials to create wood pellets so that they can use it as biofuel. So here they're using, it's close to being carbon neutral because we're using the carbon that was stored in trees to create energy. Now you have to keep in mind that we have to think that they're using waste materials from the logging industry. Is that happening really? I know that I've watched a documentary where people sometimes they take whole trees to create wood pellets for the industry. So that is something that is to think about. On this, I'm going to probably talk about it a little bit more next week, as I'm covering this week how we're using wood pellet to become carbon neutral for the energy production. However, it seems that there are some unethical ways happening. So we'll talk about that next week, and I think you will enjoy that. And this is the, let's see, so we cannot have a much smaller map. So this is what we've got in, there you go, in Ontario. So hopefully you've enjoyed that. It's always fun to learn from our areas. On this, if you have any questions about power generation in Ontario or any other places around the world, if you have fun and interesting information about electricity production in your areas, put your information in the comments below. I always read them, and I use them as a way to share more information to our audience. On this, I'm going to put here a link to an electrical, let's see, a topic about electricity, probably some circuits. I'm going to put it right here, and I'll see you in this next video where we're going to learn something